So this panel is about how foveation is opening the possibilities to more markets than just gaming, and to understand what it took to get the very first product to market with foveated rendering, or one of the very first products. With me here, I've got a good collection of guys, but first we've got a video that we want to show you, and also to let you know that we encourage photography and video. So let's get that video started first. Great. So that's a kind of an introductory clip to who's on the panel. So the other thing is I kind of wanted to set the stage for how we're defining foveation and what that really means for some people who might not know. Basically, the human eye has limitations to what it can see. And one of the purposes of foveation is to reproduce the inherent limitations of the eye, and the fact that the outside of the eye cannot see as high of a resolution as the inside, and that center area is the fovea. And basically, foveation seeks to replicate that type of human vision with a high resolution, low resolution approach. And basically, there's different types of foveation and foveated rendering. Some are fixed, while others are dynamic. And foveated rendering kind of takes into those different types of foveations into account. And we'll be talking more about that in the approach of how we started to get foveation into a headset and where that led to. So with that said, I'm going to have our panelists introduce themselves. First, we'll start with Huz.
Hi, I'm Huz. I'm Senior Director of Business Development at Tobii. I have over 15 years of experience with graphics and display. I've headed the graphics program office at Intel in the past, been a board of director of VESA, Video Electronic Standard Association. Ran my own 3D autostereoscopic venture up in Germany and Singapore, and now I'm at Tobii.
Great. I'm Dave Weinstein. I'm Director of VR and AR at NVIDIA. So I oversee kind of day-to-day operations, product management, business development for VR. My team works on partnerships, so it works closely with the great panelists that you'll see and hear from today. And as hopefully all of you know, NVIDIA makes the GPU, which is the engine that's driving all of the graphics, And with our newest line of GPUs, the Turing RTX GPUs, we introduced variable rate shading, which is one of the key technologies. So looking forward to telling you more about that today.
Hey there, my name is Vinay Narayan. I'm the Vice President of Platform Strategy and Developer Community for HTC Vive. And a lot of what we do is a lot of companies, actually a lot of folks know HTC as primarily maybe an HMD or hardware company, but we're much more than that. Whenever we've kind of built our products, we really have taken a platform approach to how we build things, meaning that they're extensible, you can add on to them, and they're great platforms for partners and developers to come together to come up with new innovations, just like with Pro-I.
I'm Nathan Nasri, CEO and founder of ReinVR. We do architectural visualizations and 3D simulations for real estate developers. My background is in video game design, and then I also grew up in a family of real estate developers. So as soon as I tried the Vive, actually that was kind of the light bulb moment for me, where I said, okay, I could use this to sell a lot of houses. So that's how I started the company, and been developing with the Vive ever since. And
I'm Anshul Sag, lead AR/VR analyst at More Insights and Strategy, and I, have been covering this area for at least 5 years now. So I'm very honored to be among these guys and to moderate this panel. We're going to start out with questions. I've got a bunch of questions, and then towards the end we'll have about 8 minutes for Q&A from anyone in the audience. So I'll kind of just get things started. So I'll start with Huz. I heard that Tobii is announcing its Spotlight product, and it's a feature in the new HTC Vive Pro-I. So what exactly is Tobii Spotlight?
So thanks, Anshul. Thanks for introducing foveation as well. Tobii Spotlight technology is an advanced Tobii eye tracking signal specialized for foveation. It has superior characteristics of an improved signal reliability, better frequency, improved latency, better frequency and noise handling.
And what is the underlying technology that's behind Tobii Spotlight?
So with Tobii Spotlight technology, we try to mimic the eye, right? You're kind of trying to mimic how Mother Nature reacts. For example, when your eye moves, rotates 0.3 degrees, there's a 1 millisecond add-on to that, right? If you use a naive foveation signal or an eye tracking signal, add another 30 milliseconds of, trying to capture where your eye is and trying to see where it is. So if you're looking here and then you move, your signal's trying to capture that. And then there is more latency added with respect to the display, the tracker.
So speaking of other Tobii eye tracking products, how is Spotlight different from just Tobii eye tracking?
So Tobii eye tracking is all about signal reliability, population density, or angular accuracy. With Tobii Spotlight in particular, the signal is far more improved, right? It takes care of latency, takes care of frequency and noise along with it.
Okay. And that's a great foundation for what I was going to ask next, which is about variable rate shading. So Dave, could you kind of give us a little bit of information about what VRS is and what the benefits are?
Yeah, sure. So if we pop up a level for a second, VR is both sort of the best magic trick we've ever seen, and also a grand challenge problem, right? How do you put someone in an environment and convince them that they're no longer here in this room, they're in an environment that you're rendering? Doing that is really hard, not because it's hard to make something that's photoreal, but because it's hard to make something photoreal at 90 frames a second. And so to do that, we've had to find some optimization, some efficiencies. So one of the efficiencies is I don't have to render all of the pixels at the highest resolution, right? And going back a couple of generations to NVIDIA's Maxwell generation, we introduced multi-res shading, where we would do higher resolution in the sort of center, lower resolution in the periphery. Then with Pascal, we kind of further fine-tuned that. You had a nice linear fall off between the sweet spot and the surround. but it was a little bit difficult for developers to use. And so with this generation, with Turing and RTX, we've taken a different approach. We've basically said, okay, developers, we're going to give you this different SDK. And the way that this SDK works is you're going to allocate a buffer that's roughly the size of your image plane. It's actually sort of a quarter of that dimension in each axis. And inside of here, you're going to tell us how much sampling you want to do for your shaders, right? And so this idea of I can specify that in this region over here, I want to do more sampling, right? I want to do super sampling. And in this region over here, maybe I want to do coarse sampling. That concept is variable rate shading, right? Now, there's two flavors of variable rate shading. The first flavor, which is tier 1 variable rate shading, says from the time that I start a draw call, and then I'm going to shove a bunch of geometry down, to the time that I stop, I get to specify what sampling rate I want to use for that geometry, right? So I could say that my whole scene should be super sampled, or this half that's in the draw call. Then there's tier 2 variable rate shading, which says, actually I want a little bit more control than that. I want to be able to specify it on kind of a per polygon basis. I want to be able to say, these polygons over here should have super sampling, or I want to be able to say, this region of the screen should have super sampling, right? That tier 2 VRS is only available through Turing RTX today. So that's the one that is kind of perfect for VR, right? Because with Tobii eye tracking, I know where you're looking. And not all pixels are created equal, right? The ones that you're not looking at, you don't really care about. They've got to be roughly correct. You can't have things popping in and out. But I'd much rather optimize and spend the horsepower in the area where you're looking. And again, VR is kind of a grand challenge problem. So if I'm going to have to solve this optimization problem in order to get a frame out every 11 milliseconds, I want to do the most work in the area that's going to make the biggest difference.
Okay, so you spoke about developers and implementing VRS. What does it take for a developer to implement it, and has it gotten easier over time? Like, is there something that you guys have done to make it like a more smooth process than it has in the past?
Yep. So we've done two things to make it easier to use. One is the way that that our previous technologies worked required sort of multiple passes through your scene, breaking up the tiled image display. With VRS, developers don't have to do any of that. They just have to allocate a frame buffer that's going to be your VRS mask and use it. We wanted to make it even easier, though, than that. And so we created something called VRS Wrapper, right? And the idea for VRS Wrapper is, although there's lots of things that you could do with variable rate shading, the main thing that people want to do in VR is gaze tracking, right? And so let's create an easier to use API where users don't have to allocate this buffer, and they don't have to go through and define the ellipsoids. They can just set a few parameters and go, and it all just works, right? So we created VRS Wrapper, and it's available as a plugin to Unity. Works awesome with Vive Pro Eye. And so if you're a developer and you're using Unity, you can just drop this as a plugin into your application. You set a few parameters and it just works, right? So VRS Wrapper was meant to lower that bar. Again, it's for Unity. It's for forward rendered applications that are using DX11. If you don't fall into that camp, then you have to write some code yourself to allocate this buffer. It's not rocket science, but you are writing some C++ code. And we have APIs available for DX11, DX12, OpenGL, Vulkan, all of them for kind of the vanilla VRS.
And are there any applications that are already out today that use VRS?
Yeah, there are. There's a handful of them. They're great experiences. So Ovation VR, where you get to stand up on stage and present to a group, and it's for getting people prepared for that, is a great application that integrates eye tracking. There's a Major League Baseball one, which is great. As the pitch is coming at you, it's tracking your gaze direction. And there's another application that we're showing off For those of you who are here for another couple of days, I encourage you to go by the PNY booth. They're showing Autodesk VRED, which is integrated VRS.
I saw that.
Yeah, right. It's a great demo, right?
It
It's
is,
using
definitely.
using the Vive Pro Eye with the gaze tracking, and again, for automotive materials, which are really complex, you need the ability to super sample the hood of that car, right? And so again, using the power of VRS for that application.
And what do you see as the future for VRS? Like, what are future potential applications for it that maybe aren't being used today?
Yeah, so the area that I'm, or the future direction that I'm most excited about is tying in ray tracing with VRS, right? And the concept here is for a raster display, for a desktop monitor, I need to refresh every pixel on every frame. And the graphics pipeline is kind of set up for that, right? I'm going to render all the polygons, and that's just what happens on every frame. For VR, those pixels that I'm looking at, those need to update, and I need to be able to spend more budget on them, less so in the periphery. And ray tracing is actually kind of the perfect pipeline for that. And so, as we march forward and we start to see applications that are integrating ray tracing into VR, VRS and next generation VRS, where again we're able to give the graphics cards hints, clues about where the user is looking and which content is the most important. Those are going to drive where the rays are cast and where the image quality is the highest.
Great. So one of the questions I had was if there's any benchmarks or that you can share with us that showcase the benefits of foveation and how it leads to better devices and better experiences. Both Huz and David, I'd love to hear about that.
Okay, so yes, there are some benchmarks around VR in general that can show this off. The question is a little bit tricky because again, what we're trying to do is solve an optimization problem, right? I want high image quality in the region that you're looking at, lower image quality in the periphery where you're not going to notice it. So if you give me an application that just barely comes in at just under 11 milliseconds per frame, I'm not going to change that because it's for VR. There's no benefit to rendering a frame in 6 milliseconds. Instead, I'm going to reduce my resolution in the periphery, increase my image quality in the foveated region, and still hand you back an application that's running at 90 hertz, right? So I haven't changed the performance characteristics in that case. I've improved the image quality. By contrast, if I have an application that is missing frames, that takes 15 milliseconds per frame, in that case, I'm going to step things down a little bit. I may not actually improve the image quality in the central region where you're looking, but I'm going to drop the image quality, do coarse sampling out in the periphery to get you under that 11 millisecond budget, and now your VR experience is better, it's smoother, but I didn't actually improve the quality, but I did improve the performance. And so you've got this knob that you can turn, actually two of them. One that's saying what quality, how much sampling should I do in the periphery, right where you're looking, and then there's kind of a third one right in the middle. So you can dial those up and down. And then you've got a second one, which is how big should the foveal region be, right? You guys gaze track super fast. But my eye also moves super fast, and so I need a little bit of margin on either side, right? And so you can dial that up or down as well. And so you've got these two knobs, which is why it makes it really hard to answer the question of just performance benchmarking. I think of it more as this is another tool that you can use to optimize.
So to add color to what Dave, I think that was so accurate, right? Tobii's research team, engineering team, along with NVIDIA and collaboration with HTC, we did some benchmarks on some games and enterprise applications. We noticed up to 50% GPU rendering improvement, 57% GPU rendering improvement. We saw some shading rate improvement up to 16%. So when your GPU rendering load is 57% better or better, you get better image quality, better resolution. So these are early numbers coming out. We've published them. I think there's a white paper coming out soon in the next couple of months. But these benchmarks look amazing that you can apply to different applications and in different industries. And we've done all this on HTC Pro Eye.
This is a good point. I just wanted to add one last thing. If you think about how big is the area of foveation, just from an anatomy point of view, it's very small, right? You're talking about just a few degrees. Yep. And so when you project that onto a display and you give it a little bit of border, you're still talking about less than 25% of the full frame, right? So if I can optimize and just do full res, full quality rendering in there, yes, and do lower quality in the periphery, it's a huge win, right? You're dramatically reducing how much work you're doing in over 75% of the image.
Great. So Vinay, you guys helped bring this headset to market with all these capabilities. Could you tell us kind of how you came to that conclusion that you guys wanted to integrate eye tracking?
Yeah, I think for us, when it comes to technologies, we're looking at technologies that are very foundational, meaning you're going to invest in these technologies today, but a lot of your experiences are going to be for tomorrow. So we want to make sure that we bring the most meaningful innovations into VR. And as you kind of heard even Dave talk about some of the complexities around foveated rendering, setting up VRS. In fact, actually not setting up VRS. Actually, VRS brings the simplicity that eye tracking previously did not have. It was very difficult and complex to bring in those technologies into your environments. But in collaboration with Tobii and NVIDIA, VRS Wrapper, for example, was pretty quick. It's actually extremely quick. So you don't have to be an expert in eye tracking to be able to do that. But equally as important, when we looked at what's the next big innovation, what's really needed, we saw that it's really about innovation that allows other experiences to happen. And eye tracking really is that. Today we're really talking about foveation and foveated rendering, but there's a lot more than just foveated rendering that you can do with eye tracking. If you've ever done the MLB experience, for example, being able to kind of be in position without controllers to be in a bat, but then to actually look and navigate the menu without having to get up out of position, when you do something like that, it's intuitive, it's native. Eye tracking with VR finally feels like the way you thought VR should be, natural. And it was around the right amount of time. It's taken many iterations for that technology to get here. The other thing that we wanted to actually look at is it's actually easy to create a new headset. But given our partners' feedback, developers' feedback, and with Vive Pro is really the industry standard for enterprise VR. But if we just created a brand new headset with a brand new architecture, we knew that we would actually place a lot of friction in your existing investment. So we wanted to make sure that we gave you the right level of improvement for this technology, and that's why we created Pro Eye. Pro Eye really enables the industry to leverage their existing investment in Pro and in Vive and add the incremental improvement that you need to. So you no longer have to replace all of your headsets or the development of pipeline. So really combining those two, the right timing for the industry, the needs for the industry, and actually having that platform approach is really how we came about with Pro Eye.
Thanks. So how and when did you approach different vendors to be able to integrate this dynamic foveation that you have in the HTC Vive Pro Eye?
Yeah, I think whenever you're looking at kind of a new product or pipeline R&D, it's usually about typically 2 to 3+ years to take innovation and bring it into the market. So we've been looking at eye tracking for quite some time, actually, before even the original Vive launched. So it's been many years that we looked at that. One of the things that we look at, and I think HTC has always been great at, whenever there's a new industry, new innovation, or emerging category, we've always been there. We've done that in our mobile days, we've done that in VR, and now the next iteration of VR. But we've also leveraged our partners. We have some of the best partners in the world, and we also look for the best partners in the world. That's why we partnered with Tobii, a leading expert in eye tracking, but also work extremely closely with NVIDIA, because NVIDIA does something that's also really great, makes it easy for developers. So as we looked at eye tracking for many years, we also wanted to make sure we brought it into the right time with the right combination of platforms and technologies and SDKs that makes integration of eye tracking as easy as possible.
And you kind of led into that a little bit, but why did you guys choose to build a headset with dynamic foveation now?
I think it was definitely the right time. What we're seeing is kind of an intersection point of meaningful integrations. What we're seeing is industries that have invested and developers that are invested in VR are looking to take that other next step approach. This is really that next technology. We talked about optimization earlier. So when you have content that's optimized up to 57% in shading improvement, what that really does is also enables that same content to work in other industries. There are certain industries that are very graphics intensive. They have the GPU stack to enable high poly experiences. But what about those that still want the high level of quality, but don't actually have that existing base of GPUs? With this technology, you're actually incrementing or increasing the amount of markets you can actually penetrate with your existing content. So it's really that there's already a great amount of investment. A lot of companies and enterprises and developers are looking for kind of the next evolution into VR. And really eye tracking this was a perfect timing for that.
Okay. And the other question I had is kind of a follow-up to that is, how do you think foveation is going to change the VR landscape compared to what it is today? Like, how are things going to be different?
Yeah, I think it's going to be table stakes for a variety of reasons. One of it is just extremely intuitive. For an end user perspective, as I mentioned earlier, it is the type of VR experience you thought you should have. We talk about a little bit, if you haven't seen a foveated rendering example or experience, a lot of those outside of your pupil kind of drop-off areas, they're not noticeable. And so for an end user, that's great. Same thing with eye tracking. So you're going to see that in other devices as well. But also when you talk about performance improvements, this really does enable headsets to become smaller and lighter. It does also enable things in the future like split rendering and also enabling cloud-based solutions. So there's a lot of things you can do. But we understand that, and that's why our approach to eye tracking also incorporates a lot of those innovations. We're very confident by working with Tobii and with NVIDIA, your investments today for Pro Eye will also enable you to take advantage of those future integrations for tomorrow. And we're working very actively to make sure that those experiences happen.
Cool. And kind of along that line, what do you guys see as the future of foveation for HTC Vive? Like, where do you see this coming down the line for the company?
Yeah, while we don't really talk about our future roadmap or products, I think the biggest opportunity is today. We're just scratching the surface of what eye tracking and foveation can really do for the market. And that's why we really take a developer and community-based approach. And really hats off to the Tobii team and NVIDIA for having open SDKs. A lot of these APIs and SDKs that are enabled with the Pro Eye used to cost a lot of money in previous generation eye tracking headsets, literally hundreds of thousands of dollars worth of licensing that are available out of the box with our SDK. And the reason we did that is because just like when VR first started, really the community came up with all those great user experiences and innovations, and we feel that that's what the future of Pro Eye is today.
Cool, thank you very much. So Nathan, I had a question for you. Can you tell us a little bit about who your customers are and what you guys are doing in the VR space a little bit more in depth?
Yeah, so our customers are real estate developers or architects who have to communicate the vision that they have to sell to someone that's eventually going to live in this space or lease it or work in that space. So one of the biggest benefits, of course, is the quality. And I think that the quality improvement that you get without needing to sacrifice spending more money on more expensive hardware, which can be a big turnoff to a lot of our customers who think that, oh, in 6 months I'm going to have to buy something new. But this sort of sets like the floor of now we can just keep building from here. Like you're always going to have extremely high quality with extremely good resolution, and you're not going to have to go back and buy another HMD or another video card the year after unless you're looking to make a substantial improvement. But right now I think what we're finding is our customers are really excited about the potential of eye tracking, mostly because when you're talking about a house or where someone's going to live, there's a lot of intangibles. Like someone would say, this doesn't feel like the right house for me, or this doesn't feel like a place that I could call home. And those are really key indicators because now we can actually track what someone's looking at within the house and get some good insights as to if someone says this doesn't feel right, we might have a good indicator that they just didn't like the bedroom. Because it's really hard for someone to quantify what they don't like in a house because it's such an abstract thing and it really ties into human emotions. So having those key performance indicators, I think, is going to be really useful, not just in terms of how these homes are designed, but in terms of how they're marketed and sold in the future. So I think this is really like, like you've been saying, Vinay, is like this is the breakthrough that the VR industry has been looking for, and the intuitiveness of just using your eyes to manipulate the world around you. It's so natural. It just feels so much better than using a controller or even trying to educate someone that's never used VR before, versus saying, okay, look here and then look there, and it's just going to work, versus this is the button that you need to press, and maybe they've never held a gaming controller in their life. So it's been, very, very exciting for us, because now we feel that it's a much more natural path forward where you don't really need to spend 30 or 60 seconds explaining it to someone.
So you mentioned KPIs. What are the KPIs for you and your customers when it comes to foveation and VR in general?
Really, it's just the quality of the image. So if someone goes into our VR experience and looks over the balcony and gets vertigo, that's a key performance indicator that we've done our job properly, because it goes beyond your comprehension of saying this is a fake world, this is not real, I'm not in danger, and your subconscious just takes over and says, no, I'm on this balcony, I am in danger, and you need to step back away from that edge. So that's really for us when someone comes out of VR and says like, oh my God, I felt like I was there, or can I please go back to that apartment or that house, because it's just so immersive, and that's really the key performance that we're looking for.
Okay, and what are your kind of expectations from a headset manufacturer like HTC?
Good question. Just to rag on you, just don't release a headset for a while. I mean, there are so many of them now. But hopefully with I think with the eye tracker, we're really at the precipice of being able to say, this is the solution that we're going to suggest for your business, and you won't need to upgrade for a considerable amount of time. Whereas before, the VR industry has been very volatile, and there's been new headsets coming out, but that's just because we're trying to get to sort of the ceiling of human eye resolution, and I feel like we're pretty much there now. So I don't know how much better. There's really no advantage of rendering something better than you can see, other than just spending more money. So that's really what excites our customers about this, is now and we can actually say with confidence, like, this is the device. Like, you don't need to go out and spend another, $5,000 to retrofit all of your existing sales offices. You can just go with this headset, and we know it's going to be this one for quite some time.
Cool. And when it comes to deploying a customer-facing HMD like the HTC Vive Pro Eye, what are some of the insights you've gained that were unexpected?
Don't use it near windows. That was one of the things that we learned. And don't use it outside either. That was another thing that we learned the hard way. But the tracking's gotten much better. And really what we found is that a lot of our customers don't want to allocate as much of their sort of real estate towards a virtual experience. But now that they've seen the power, and we've been seeing extremely positive results. For example, one of our projects just sold out entirely using VR, and all they built in their sales office was a kitchen. So they didn't build any replica suites of any of their products. They just basically said, we're going to build a kitchen, use the Vive to showcase everything else, and it was very, very successful for them. So I mean, that's the kind of those are the kinds of lessons that we've learned, is that maybe a few years ago, this was kind of seen as a fad or like a cool marketing gimmick that they could do. And I think now it's past that threshold where people are seeing tangible results of spending millions of dollars less in their sales operations and reaping the benefits just as if they had spent those millions of dollars.
So I know, and you've been talking about this a lot, with the whole real estate market getting very excited about VR. So what are some of the ways that Foveation's been able to deliver on those excitements around VR?
Well, I think if you could imagine if you are a salesperson trying to sell a property to someone, and you can get a very good understanding if someone comes out of VR and says, yeah, I didn't like that, you'll have the results in front of you, which we can use machine learning to determine, if someone spent all the time looking at the furniture and they come out and they say, I didn't like that house, they probably just didn't like the furniture. It has really nothing to do with the house, but they can't really tell you, oh, I didn't like the furniture in the house, therefore I do not want to purchase it. Or if you are showing someone one color package where the cabinets are white and the floors are black, and they say, I don't like that, and all of a sudden you switch it so the floors are white and the cabinets are black, and they say, yeah, this is the house that I want. So you'd have some really good key performance indications for the sales team to bring up in the sales cycle. Similar to what you saw in the video, where we had a statistic of 38% of the user's time was spent looking at the stove, and 1% of the time was spent looking at the view. So if you're trying to get them to purchase that home, the last thing you want to do is say, wow, that was a beautiful view in that house, right? Because that person did not care whatsoever about the view. They cared very much so about the stove and the cooking range. So you could bring that up in conversation and maybe ask them, do you cook at home a lot, or is a gas stove something that's very important to you in your next house? Whereas before, you'd just be completely guessing. And that's just really something I learned when I was in sales, is that you can't really dig this information out of a customer because they know that you're trying to get them to purchase like the most expensive thing they're ever going to buy. But if you have the eye tracking enabled, then you don't even really need to ask them. And more importantly, you know what to ask and what not to ask in order to move the sale forward.
Cool. And related to insights and integration, I was kind of curious, Vinay, if there were any things that you guys have learned while integrating and kind of building out foveation into the headset.
Yeah, I think there's definitely a lot of key learnings. One of it's just the depth of insights you get from actually having purposeful VR experiences. That level of user insight and behavior goes a long way. You've seen kind of before heat mapping of where you see kind of density of where you're looking, but actually understanding intent and why someone's looking at those areas has really helped to kind of develop much more richer, more meaningful experiences. And so if you kind of look at, there's so many different combinations of things as you pull together between foveated rendering, gaze tracking, and the analytics you get from those combinations. What we're seeing is actually new industries or new revenue streams open up from existing content. We're seeing a lot of developers get really excited about taking their existing content and actually understanding a little bit more about user behavior and either dynamically changing it to match the user behavior or understanding what they can do better in those different scenarios, whether it comes to design or collaboration. You can actually have a conversation, for example, with somebody, and if that avatar's eyes are blinking, you have a higher chance of actually engaging with that avatar, and you can do that with eye tracking based headsets. So we're seeing a combination of many different things. In fact, we talked about earlier about Vive being that platform, so we've seen developers take our Vive trackers. We even have a lip tracking module for developers and actually do full-on avatars that actually have really good lip tracking, facial tracking, and body movements to create avatar models based off of AI that you can have a technology or solution that's much more richer, more engaging than anything else out there in the market. So definitely a lot of things we've seen happen, and I feel like the more and more we talk about it, the more hackathons, the more workshops we do, the more great experiences that we're getting out of this.
Great. And Dave and Huz, if you guys have any feedback on that in terms of, some things that you didn't really expect to happen, or, what kinds of improvements to experience may have existed as a result of adding foveation?
Yeah, I think, back to what I was saying at the very, very beginning, this is a great magic trick. We're trying to convince people that they're somewhere that they're not. In order for that to be useful, in order to be able to sell a home doing that, or design a car doing that, the rendering quality needs to be really high, right? If you put someone in a cartoony looking house and you say, hey, would you like to spend $1.2 million buying this house? You're not going to drive a sale. If you have something that is a really good surrogate for being there, then you can drive sales. And so, what foveation allows to happen is we can create photoreal experiences for people beyond what you could do if you had to render the full screen just by focusing resource on that portion that they're looking to. So it really kind of up-levels the quality of VR experiences. Again, in the beginning, VR was a spectacle, right? Everybody wanted to put on a headset and try the thing where you are on a balcony and see if you can make people step off. VR has transitioned, right? VR is now a tool that people are using in their day-to-day work, whether it's designing cars or practicing surgeries or treating patients for fear of heights or post-traumatic stress. And so, as VR completes this transition into return on investment, it's all about outcomes. These things are measurable. And I think we're going to see kind of that tipping point where it's not terribly cheap to get into VR. You're looking at some amount of expense, but it's completely justified, because if you do this as an architect, as a real estate salesperson, you will drive 10x that in additional income. And so I think as we kind of complete that transition from spectacle to useful day-to-day tool, it's going to be essential that we as the technologists can deliver experiences that are totally immersive. And foveation is one of the tricks that we have to use to create that.
Yeah, from our point of view, I agree with Dave here. In addition to, initially it was VR was about gaming. It's now expanded with foveation into other enterprises, right? It's gone into real estate, healthcare, automotive, manufacturing. That took us by, like, hey, were we prepared for this or were we not, and how do we react from here on? Because the demands in enterprise are much more accurate, much more precise, and they want a much higher performing device. And HTC Vive Pro I, along with NVIDIA, really puts that together. And we've seen those market expansions happening. So that's how Tobii looks at it.
Cool. Thank you very much. We're kind of nearing the end of the panel, so I was going to give each of you guys a chance to kind of give some parting thoughts on your views on foveation, foveated rendering, and kind of where we're going as an industry. So I'll let you go first, Huz.
Yeah, beyond the moving into other industries, I think as a developer, as a consumer, as an enterprise business, as a manufacturer for devices, or the game is now open, right? I mean, you have an ability to bring an immersive experience with your VR or your XR device or a PC for with Tobii Spotlight technology. So I think the market's open.
Yeah, I feel like maybe we're preaching to the choir a little bit. Looking out in the audience, there's a lot of VR enthusiasts out here. They're here because they're excited about realism and VR and immersion. I'm hoping that we can give them a chance to answer a question or two. So I will stop talking so that you guys can answer. You guys can ask questions that we can answer.
I agree with Dave there, but I just want to leave everyone with kind of a thought too. We know when HTC builds products and goes involved with partnerships, we're really looking at the long-term ROI for our partners and developers that invest in our platforms. And that's why we're very committed to make sure that the hardware and the products that we build today have a usefulness that goes beyond even kind of your current product ideas, and definitely for enabling the future experiences.
I think my biggest takeaway is, again, looking to the future and where this technology is going, which is the cloud, so you don't need to purchase a GPU locally and have this running, and especially with 5G coming online any day now. I think that's the most exciting thing of where we're heading to is, being able to put on a headset, have it tether free, and go into a world that, and have that dream or have that magic, experience that you just can't do today because there is so much investment involved. But I know that the cables are coming out, and that we'll be able to have a much more versatile and useful enterprise application. And it's just sort of like today is just building the foundation, and the future is going to be extremely exciting to see, especially with this technology.
I just want to say it's great to have such an amazing collection of technology leaders on the panel, and thanks for enlightening us on how difficult it was to bring it to market and what was necessary, and how much we're kind of expanding the possibilities of VR. So thanks a lot.
Thank you.
Thank you.